And subtracting algebraic fractions. We already know, as with adding fractions that do not involve algebra, we would find the lowest common denominator to add two fractions together. In the same way, if letters are involved, we will still find the lowest common denominator. Right, we see a 4 and a 5 in the denominators here. The lowest common denominator is 20 because they both go into 20. 4 goes into 25 times, so we can put a 5 here. 5 goes into 24 times. 5 times A is 5A. And 4 times B is 4B. Put that plus in the middle. It doesn't simplify any further. If you notice an answer factorizes, you should factorize, but 5A plus 5B does not factorize. So let's move on to another one. Here we have 3x over 5 minus x over 3. The lowest common denominator of 5 and 3 is 15. 5 goes into 15 3 times. 3 goes into 15 5 times. And now you multiply. 3 times 3x is 9x. Minus 5 times x is 5x. 9x minus 5x is 4x over 15. Do these two simplify the 4 and the 15? No, they don't. So you're always checking your answer if it simplifies further, if it factorizes, anything that makes it look more simple. Let's move on to this one here. The lowest common denominator is 10. 5 goes into 10 twice. 10 goes into 10 once. 2 times 2 minus x. I like to keep the brackets in here just to make sure I don't make a mistake. You can do it directly if you want. It's just that when you come to a minus, one with a minus, you have to be careful. 1 times 3 minus x. I could just write 3 minus x. I'm going to keep that 1 there just to be safe. Okay, now I'm multiplying out. 2 times 2 is 4 minus 2 times x is 2x plus 1 3 is 3. And 1 times minus x is minus x over 10. Collect your numbers together, collect your letters. I'll collect the numbers first because they're both positive, and I like to have my positive first. 4 plus 3 makes 7. Minus 2x minus x comes to minus 3x over 10. Does anything factorize? No, it doesn't. That's the simplest form we have for this one. Let's look at this next one. The lowest common denominator between 5 and 6 is 30. They both go into 30. That's the smallest number they both go into. 5 goes into 36 and 6 goes into 35. We now multiply. 6 bracket times y plus 3 minus 5 bracket y plus 4. So 5 times y plus 4. We then multiply the brackets out. 6y plus 18 minus 5y minus 5 times 4 is 20 over 30. Now, you have to be careful here because if I'd done this directly here, I would have said minus 5y, which is correct down here, minus 5y. But then I could have easily just said 5 times 4 is 20. Can you see that it's not a 20, it's a minus 20? That's why, especially when there's a minus between the fractions, it's important to do it the bracket method if you're not already going to remember that it's 5 times, change the sign, minus 4. Okay, so you would not put 20 here, you'd put minus 20. 6y minus 5y is y, 1y. 18 minus 20 is minus 2. That's my final answer. It doesn't simplify any further. That's the fourth example. Let's have another one. Right, here, a simple extension of what we've been doing so far. We have a 3, a 4, and a 6 at the bottom. If you want to find the lowest common denominator, just take the highest number in the denominator, which is 6. 3 goes into 6, which is cool, but then 4 does not. So we have to think about what the lowest common denominator between 4 and 6 is. Do not just multiply them together and say 24. Look at multiples of the biggest one, which is 6. So 1 times 6 is 6. We said only the 3 goes into the 6. The 4 doesn't. So let's try 2 times 6. 2 times 6 is 12. Does the 4 go into 12? Yes, it does. So 12 is the lowest common denominator. 3 goes into 12 4 times. 4 goes into 12 3 times. 6 goes into 12 twice. And now we proceed. 4 times x minus 3 plus 3 times x plus 5 minus 2 times 2x minus 1. Multiply out your brackets. 4x minus 12 plus 3x plus 15 minus 4x plus 2. Minus 2 times minus 1 is plus 2. All over 12. Now, looking at the x's, 4x plus 3x minus 4x. I can just cancel the 4x minus 4x. And my total is 3x minus 12 plus 15 plus 2. I'll say 15 and 2 makes 17. 17 minus 12 is 5 over 12. Does it simplify further? No, it doesn't. It doesn't factorize. It doesn't simplify. Okay, you cannot just cancel the 3 with the 12. Remember, because you've got a plus in between, it's not a times. Now, what about fractions that have unknowns in the denominator? The denominator is not always going to be a number. Sometimes you will have letters at the bottom. So the unknown here, x, is at the bottom. We'll call it an unknown, but it's a letter really. Okay, so if the denominators are the same, there is an x here and there's an x here, the lowest common denominator must be x. Just like if we had a 7 here and a 7 here, the lowest common denominator is 7. We just add the numerators, don't we? So x is the lowest common denominator. 4 plus 5 is in the numerator. 4 and 5 make 9 over x. Number 7. Okay, here we have two different numerators. One's a number, the other one's a letter. We have 5 and x. Imagine this underneath was a 3. Wouldn't the lowest common denominator be, well, if it's 5 and 3, it would be 15. So that's the equivalent of multiplying them together, is it not? So we'll say the lowest common denominator is those two multiplied together, which is 5x. Now, what do I multiply 5 by to end up with 5x? 5 times x will give me 5x. What do I multiply x by to end up with 5x? X times 5 will give me 5x. Now we multiply the numerator with whatever we had multiplied the denominator by to end up with this new denominator. So x times 4 is 4x plus 5 times 2 is 10. We notice that the numerator can actually be factorized. We have a common factor here. The common factor is 2. They both divide by 2. So 2 times what will give me 4x? 2 times 2x plus 5 over 5x. Why did we need to factorize at the end? Because this 2 might have actually cancelled with a number at the bottom, but it doesn't in this case because this is an odd number. But if that was another number, like it was an 8x or a 6x or something even, I could have actually cancelled down even further, simplified even more. In this case, it's not, but the best answer will always be a factorized answer, if possible. Right, looking at this one here. Again, we have two different denominators. So we will say our lowest common denominator is 3 times a, which is 3a. 3 times what will give me 3a? 3 times a. a times what will give me 3a, a times 3. We now multiply our numerators. A times ab will be a squared b, plus 3 times 4 will be 12. Does it factorize? No, it doesn't. That's my final answer. Number 9. We're looking at the denominators again. The lowest common denominator, well, we look at the numbers first. 2 and 3. The lowest common denominator between 2 and 3, the lowest common multiple, will be 6. They both go into 6. We have b here and b here. So that's exactly the same. Just like on the previous one here where we had x and x, the lowest common denominator was x. The same here, b and b, so we can say the lowest common denominator as far as the letters are concerned is b. So my lowest common denominator is now 6b. What did I multiply? What do I need to multiply the 2b by to end up with 6b? I multiply by 3. And what do I multiply the 3b by to end up with 6b? I multiply by 2. I then multiply my numerator with that number there that we have in the hat. 3 times 3 is 9, plus 2 times 4 is 8. Does it simplify further? Yes, it does. 9 plus 8 is 17 over 6b. Does it simplify further? No. 6 does not go into 17 exactly, so that's my final answer. Let's look at another example, example 10. Here we have two different denominators. So we're looking at these two different denominators. Just look at them as if they are two different numbers. So they're two different numbers, so we have to include them both in the denominator. We have x plus 2 multiplied by x minus 4 is my new denominator. What do I multiply this x plus 2 by to end up with x plus 2 times x minus 4? Just write down the one that's missing basically. I need to multiply by x minus 4. And what do I multiply x minus 4 to end up with this new denominator? I need to multiply by x plus 2. So we now do our multiplication. X minus 4 times 5. I'll put the 5 first because it looks neater. 5x minus 4 multiplied plus 3 times x plus 2. I will now multiply those out. 5x minus 20 plus 3x plus 6 all over x plus 2, x minus 4. Does this simplify further? Yes, it does. 5x and 3x make 8x. Minus 20 plus 6, or 6 minus 20, is minus 14. Over x plus 2, x minus 4. And we can go further here because the numerator actually simplifies even more. So 2 is the common factor on the numerator. X minus 7 over x plus 2, x minus 4. Does it simplify further? Does anything cancel? Maybe this x minus 7 with something on the bottom? No, it doesn't, because nothing is actually the same. So that's my final answer. Okay, so that's that one done. Now let's look at this one here. I've just changed the letter into an A just to make it a little bit more creative. Okay, so we're looking at the denominators. The denominators, we have A minus 1 and A. So if, say, A was 5, this would be 4. And my lowest common denominator for 5 and 4 would be 20. I just multiply them together, just like I just did for the last one. So I'll put the A first, and then the A minus 1. And now I'm thinking, what do I multiply that A minus 1 by to end up with this? I multiply it by A. And what do I multiply this a by to end up with a times a minus 1? I multiply it by a minus 1. A times a is a squared minus a minus 1 times a minus 1. That's a minus 1 squared. Okay, I'm going to take this exercise, I think, down here below, because I've run out of space there. Right, so I'm looking at this here, and I need to remove that bracket. If I can't do it straight away using the automatic method, I can just write it out twice. The a minus 1 squared, I'll just say is a minus 1 times a minus 1. So that's a squared minus a minus 1, a minus 1, all over a times a minus 1. And then moving on with that, I'm going to expand this bracket. A squared minus, there's a minus in the front. So when I expand this, make sure you put this bracket here, otherwise you will have a problem with your signs. A times a is a squared minus 1a and minus 1a again. Or you can just say minus a again. And then minus 1 times minus 1 is plus 1 all over a times a minus 1. We carry on working the numerator. A squared minus 2a, because that's minus a, plus 1. All over a times a minus 1. Now let's remove that bracket. So you see how careful we are as we go along, especially because there's a minus in front of this, which will change all those signs now. So we have a squared minus a squared plus 2a. So the sign has changed, and minus times plus 1 is minus 1. All over a times a minus 1. Immediately we notice that these two cancel, and I'm left with 2a minus 1 over a times a minus 1. And that's my final answer because the numerator does not factorize. Let's move on to this one now. The lowest common denominator here is x minus 1 times x plus 1. So imagine that's two different numbers underneath. Say this x was a 4, this would be 4 minus 1, which is 3, and 4 plus 1, which is 5. So if I had a 3 and a 5, it would be 15, my lowest common denominator. So it's just two different things, so I put them both underneath. Right, so x minus 1 times x plus 1 will give me that numerator. X plus 1 times x minus 1 will give me that denominator. Okay, so we're trying to get the denominator by looking at the denominator here and comparing it to this one. So we have 3 times x plus 1 minus 2 times x minus 1. We multiply those out, so it's 3x plus 3 minus 2x plus 1 over x minus 1 times x plus 1. Now 3x minus 2x is x, and 3 and 1 make 4 over x minus 1, x plus 1. That's my final answer. Nothing actually cancels here. Next question here, we have x plus 2 as our new denominator and x minus 1. So we multiply them. And here, what do we do to the x plus 2? We multiply it by the x minus 1, which is down here. And what do we do to the x minus 1 to end up with this new denominator? We multiply it by the x plus 2. We then multiply the numerators with the this which I wrote in the hat. So x minus 1 times x plus 1 minus x plus 2, x minus 2. And that looks interesting, doesn't it? This here we all know is a difference of two squares. We don't have to do them one by one. You can if you like. It will come to x squared minus 1 squared, which is 1, minus, and this one, if you multiply it out, will come to x squared minus 4. Don't forget to put that bracket there because there's a minus in the front, which will change these signs. All over x plus 2 times x minus 1, which is x squared minus 1 minus x squared plus 4 all over that denominator of x plus 2 x minus 1. The x squared cancels with the minus x squared. We have 4 minus 1, which is 3. So that's my final answer, 3 over x plus 2 times x minus 1. There you have it. Right, this might actually be our last one now. Now this one here, we notice is we have an x minus 2 here, and here we have a quadratic that actually factorizes. If you see that the denominator factorizes, then you need to factorize that. Okay, so make sure you factorize any denominators first when you're adding, subtracting. So, oh, hang on, mistake. Let's factorize that first before we find the lowest common denominator. So keep these separate. It's not working. There we go. Right. So we have, keep that minus there. We'll just rewrite this one on the left. And this one on the right, we will factorize the denominator. That's a quadratic, so it's an x and an x. Two numbers that multiply to give me 2, and they subtract. Their difference is 1. Is 1 and 2, so 1 times 2. We want to end up with a minus 1x, so it's minus 2 plus 1. Now we look for the lowest common denominator. Okay, we notice that this x minus 2 already exists over here. So we have our lowest common denominator. Everything that exists underneath is x plus 1 and x minus 2 is everything that exists. Right, so x minus 2 times what will give me this denominator here? X minus 2 times x minus, plus 1. And this is already exactly the same, so just put a 1 here. Because that times itself, times by 1 will come to this. So we have 2x